They call it the closest Earth-like planet. And at first, it's easy to believe. You step onto a thin strip of twilight where eternal sunset meets eternal night, and the sky looks almost gentle, like a promise. Under a dim red sun, you see mountains both ahead of you and behind you. One range glows faintly, as if it's still holding heat from some ancient day. The other lies in shadow, dark and frozen, sharp as broken glass. The landscape is quiet. Too quiet. The kind of silence that makes you think you could set up a camp, take a slow walk, maybe even forget, just for a moment, that you're standing on a world that never evolved for your lungs, your skin, or your fragile little DNA. This is Proxima Centauri b, about 4.2 light-years from Earth. Close enough to feel like a neighbor. Close enough to make people whisper the most dangerous phrase in science: we could go there. And then the sky explodes. The gentle red sun you were admiring a second ago suddenly lashes out in a violent flare. Invisible radiation slams into the surface like a cosmic hammer. Your instruments scream. Your visor flashes warnings. The air, if you can even call it that, turns into a storm of charged particles. It's the kind of outburst that doesn't just burn skin. It breaks molecules. It shreds the very instructions your cells use to stay alive. Because Proxima Centauri isn't a calm, stable star like our Sun. It's a red dwarf. Smaller, cooler, and far more temperamental. Red dwarfs can flare often, and when they do, they can bathe nearby planets in radiation again and again, like a lighthouse that's trying to sterilize everything it touches. Proxima b orbits extremely close to its star, so close that a year there lasts only about 11 Earth days. That's convenient for calendars, and terrifying for survival. When a planet hugs its star like that, it's likely tidally locked. One side faces the star forever, the other side faces space forever. Day that never ends, night that never begins. And in between, the narrow twilight band, where you're standing, seems like the only place that might be comfortable. Not too hot, not too cold. A sweet spot, but tidal locking comes with a price. The star-facing side can become a furnace. The dark side can become a deep freeze. And the planet's atmosphere, if it has one, becomes a life or death question. Can winds move heat around fast enough to prevent the air from collapsing and freezing out on the night side? Or does the atmosphere slowly vanish into space, stripped away particle by the star's tantrums? So yes, Proxima b is a perfect example of why you should read the fine print before booking a one-way ticket, or if you're still tempted to visit. You'd need sunscreen with a protection factor of 1,000,000, and at least 10 lead umbrellas, just to feel emotionally supported. You'd build your base underground. You'd live behind layers of rock like a creature that learned to fear the sky. Your morning walk would be a tunnel. Your fresh air would be filtered, recycled, and carefully rationed, because on worlds like this, the universe doesn't reward bravery. It rewards insulation, and here's the twist. Proxima b is the closest Earth-like exoplanet we know. The nearest. The one people talk about in speeches. If the closest option is this hostile, imagine what the rest of the galaxy has prepared. Because today, we are traveling to the most extreme exoplanets ever discovered. Worlds so strange, so violent, and so physically impossible looking that the only real challenge isn't the temperature or the pressure, to it's staying sane. *****, now you know not to trust a red dwarf. But the opposite extreme can be even more brutal, somewhere far across the Milky Way. There's a world often nicknamed a real-life version of Hoth, a super-Earth found through gravitational microlensing, one of the strangest detection methods we have. Microlensing doesn't watch a planet cross in front of its star. It doesn't measure a wobble. It catches a brief distortion in light when a star and its planet pass in front of a more distant star, bending space-time like a lens. It's like finding a planet by noticing the universe blink. That's why these worlds often feel like ghosts in the data, far away, hard to revisit, yet undeniably real. On this frozen planet, the temperature can plunge to around minus 220 degrees Celsius, colder than liquid nitrogen, cold enough that normal gases behave like solids, cold enough that many materials become brittle, like glass. And unlike Pluto, cold but airless, this world can still have an atmosphere, which makes the cold worse. An atmosphere steals heat from you. It wraps around your suit and carries warmth away like a thief. You step onto cracked icy plains, and the horizon stretches in every direction as a sea of shattered frost. Above you, the star is weak and red, like an ember seen through smoke. Your visor fogs instantly. Not from humidity, there's almost none, but from the brutal physics of temperature gradients. Your suit becomes a small warm island in an ocean of molecular stillness. And the universe tries to equalize you. If you absolutely must live out your Empire Strikes Back fantasy, you'll need a nuclear parka over a spacesuit, visor heaters to prevent instant freezing, and a supply of power so ridiculous it starts to sound like a myth. And yes, if you're determined to follow the old cinematic survival trick, bring at least 3 tauntauns, not because it's practical, because on worlds like this, practicality left a long time ago, but not all extreme worlds kill you with cold. Some seduce you first. Consider a system like Kepler-16, where planets orbit 2 suns. A true double sunset, 2 bright disks sinking together, throwing long shadows across dunes, cliffs, and alien dust. It's the closest thing we've found to that iconic sci-fi scene, standing on a quiet ridge, watching twin suns fall, feeling the universe pause for a moment. It really does look like a perfect sunset, and then the temperature drops, fast, without a thick atmosphere to smooth the transition. Day and night can differ by hundreds of degrees. Materials expand in heat and contract in cold until they crack. Rock fractures, metal strains, your equipment complains, then fails. Temperature shock doesn't care how advanced your technology is. It cares about basic thermodynamics. So if you want the twin sun view, pack boots that won't melt or freeze, a companion drone that can repair your gear between thermal cycles, and binoculars, because if you're out there long enough, you'll start imagining shapes on the horizon and in stories. That's where scavengers appear. In reality, it's where your fear becomes the thing that follows you. Some exoplanets belong in the category of extreme sports, and one of them tries to kill you with style. Welcome to 55 Cancri A, a rocky super-Earth about 40 light-years away, close enough that it doesn't feel mythical. It feels reachable, which makes it more unsettling. This isn't a planet where gravity crushes you. The gravity is survivable. The real problem is that the surface is a furnace. Temperatures can soar above 2000 degrees Celsius, hot enough to melt rock, to vaporize many metals, to turn familiar solid ground into something that behaves like a glowing sea. Some models suggest the day side could be an ocean of lava, a world where land is a moving, boiling skin, where the crust is constantly trying to reinvent itself in liquid form. Your visor fills with the sight of molten rivers that snake like neon veins across the surface. Above you, the sky is dim and strange, and in the wind, if there is wind, you don't get rain, you get iron snow. Tiny metallic particles can condense and fall through the atmosphere like glittering ash. It's the kind of phenomenon that sounds poetic until you remember it's made of metal at lethal temperatures. It's heavy metal in the most literal sense. Picture Mustafar from Star Wars, except here, even the heroes wouldn't have time for dramatic dialogue. They'd be flash-cooked into silence, so if you somehow had a sci-fi thermal shield strong enough to survive, you could do the dumbest, most glorious thing imaginable: lava surfing. A hoverboard skimming across molten rock while the sky rains metal around you. You would be, without question, the most stylish corpse in the galaxy, so bring aloe vera for emotional comfort. Bring a freshly signed will. And bring the humility to understand that the universe doesn't care about your courage, because it still has stranger worlds to show you. Asterisk. Some planets can't decide if they're frozen or burning. Take Gliese 436b, a Neptune-sized world about 30 light-years away, famous for something that sounds like a joke. Ice at scorching temperatures. You descend into a shimmering landscape that looks like frost under a dim orange star. Ice stretches endlessly, glittering like a field of crystals, and then your suit screams, 400 degrees Celsius. Hot enough to melt lead, so why is it still ice? Because pressure changes the rules. Under enormous pressure, water can form exotic phases, crystal structures that don't exist naturally on Earth's surface. Hot ice is real in physics. Water locked into a solid lattice by pressure even when temperature rises far beyond what we'd call melting. The molecules don't get to move freely. They're trapped, forced into order by gravity and atmosphere. It's beautiful, in a terrifying way, but don't celebrate. Pressure like that doesn't just keep ice solid, it keeps you flat, so maybe don't go in person. Send pressure-resistant probes. Watch through cameras. Use VR if you have to. Remote wonder is still wonder, especially when the alternative is becoming part of the planet's geology now. If you want something that feels like a dream, there are planets that are almost impossibly fluffy. A world like TI 6894b, nicknamed for its absurd low density, is so light for its size that it's often compared to cotton candy. A giant sphere of gas so puffy it barely seems to hold itself together. Floating in its upper atmosphere would feel like drifting through pastel clouds in slow motion. Pink haze, endless softness. The horizon glowing like a never-ending sunset. It sounds peaceful until you remember there is no ground, no surface to stand on. Just deeper layers, higher pressure, and a slow descent into crushing darkness if anything goes wrong. If your tether snaps, you don't fall onto land, you fall into forever. So bring emergency boosters, a ridiculous oxygen supply, and a tether stronger than your confidence. And if you want the opposite of fluffy, if you want something hard enough to make reality feel expensive, then you'll love the idea of a diamond planet. There's a candidate world often discussed, PSR J17191438b, a planet-like object orbiting a pulsar. Its density is so extreme that it's been described as a crystallized carbon world, something like a diamond the size of a planet. It may be the stripped core of a former star, a white dwarf remnant carved down by a violent partner. In other words, a jewel born from catastrophe. You imagine mountains of sharp crystal catching faint, deadly light. You imagine glittering ridges that look like a jewelry store exploded across a horizon, and then you look up, because you're orbiting a pulsar, an ultra-dense spinning corpse of a star, whipping beams of radiation through space with metronomic precision. It doesn't shine like a sun. It fires. And if you stand in the wrong place at the wrong time, it doesn't warm you. It cooks you. So yes, bring a Geiger counter, a drill strong enough to cut crystal, and a suit lined with enough shielding to make you feel like a walking bunker. If you're going to the edge of death, at least go with style. But if you want an exoplanet that feels like a weapon, there's one that has its own mythic nickname, Rain of Glass. HD 189733b is associated with this nightmare. High temperature winds, silicate particles, and storms where molten material can condense, leading to sideways rain that behaves less like water and more like sandblasting shards. Imagine a storm where the atmosphere itself is trying to carve you into nothing. Not a hurricane. A planetary grinder. It's less weather and more punishment. And finally, if you want the universe to violate your sense of personal space, look at Kepler 36.2 planets in the same system, orbiting so close that from one, the other could dominate the sky, huge, looming like a world hung overhead. Every close approach pulls and stretches the nearby planet with tidal forces. You feel it as constant instability, quakes, stresses, the subtle sensation that the ground is never truly at rest. It's horrifying and it's beautiful. A front row seat to a system that feels like it shouldn't exist, but does. ESO pack an exoskeleton for stability, earplugs if you want to sleep through a season of tremors, and something to calm your nerves when a whole planet drifts above you like a silent cosmic guillotine after all that chaos. Let's end with something quiet, extremely quiet. There's a planet known for being almost absurdly dark, Terrace 2b, a gas giant so non-reflective that it absorbs nearly all the light that hits it. It's darker than fresh asphalt at midnight. Descending into its upper atmosphere could feel like your visor went blind, like the universe simply switched off. Below you, an endless abyss of dark gas above you. Faint starlight failing to illuminate anything. It's eerie, but also calming. After flares, storms, hot ice, glass rain, lava oceans, and cotton candy horizons, emptiness becomes a kind of relief. The darkness doesn't attack you with drama. It just surrounds you. It swallows the edges of your thoughts until all that's left is silenced. So, if this is your final stop, bring powerful floodlights if you really insist on seeing something, and maybe keep a therapist on speed dial, just in case the dark starts to move inward. And now, after all these worlds, here's the real question. Of all these destinations, which one would you actually visit just once? And which one would you avoid at any cost? Share your most extreme choices in the comments.